one thing I want to do, and then find the lab manual as well. Okay, to share with you. Tariq, what was your question? I think your question had to do with perforated plate. Is that something in this picture? Did you find it from the? Okay. That's the columns, fractionating columns. The one that we use in the lab is like a homemade one, and we just insert like a piece of glass wool, not the glass wool, steel wool, and it's going to be used as like an obstacle, so it doesn't allow the vapor of a mixture to go up. Only the one with the lower boiling point is going to go up. But if you go with the original or better standard design of the fractionating column, they kind of use the glass, and they make kind of poke in while it's hot, so they get these extensions like in different angles, all that into the glass. So it's not, if you compare the condenser, you have like a straight line opening for the vapor to go straight down. In here, when the vapor comes in, it's going to hit these obstacles, and those are called the perforated plate. So it's basically fractionating column, part of the fractionating column. Yes, the glass itself is going to replace the steel wool because of the surface area. Perfect. Yes. Yeah. Just a normal fractionating column. Yes, very good. But is the standard or commercialized or specified for, specifically used for the fractional distillation, rather than the way that we do. We use like a condenser, and we upgrade that to this. These sometimes they used to be like $800 piece, so it requires some art, and it's expensive, but the steel wool does the work. Sure. That's the next thing we're going to do after I answer the specific questions, and then I go over the experiment actually. So let me go over the experiment here. The experiment today is looking for experiment 8. Is dehydration of alcohol. So when you have dehydration of the 2-methylcyclohexanol is alcohol. When you do dehydration, you need like for dehydration of alcohol, you need a strong acid and heat. It's going to dehydrate the alcohol. When you look at your reactant being 2-methylcyclohexanol, you get two products. You have mixture of two products. Whenever you get more than one product, then you have to have a mechanism or explanation to find out which one is the major product, which one is the minor product. You don't always get 50-50% split on the product. You get major product and you get minor product. Now, how do you get the major product? It comes from two facts. If you have more stable intermediate, that is going to yield to a more to major product, because more stable intermediate is going to form faster. It takes less energy to form, and then it can go to product faster. If you have more stable product, also could be a factor to make that product to be a major product. In this case, we are looking to see which one, because the intermediate is the same for both products. Then we have to look and differentiate between the stability of the product. Now, the product on the right side is called 3-methylcyclohexene, And then the product on the left side, this one is 1-methylcyclohexane. Which one is more stable? 3-methylcyclohexane or 1-methylcyclohexane? If the chapter of alkene has been covered already, and you have heard about safe product, we know that this one on the left side is going to be more stable. And if it's more stable, it's supposed to be the major product. The difference, you have the carbon-carbon double bond. For the one that is highlighted now, you have 3 alkyl group attached to carbon-carbon double bond. But for the carbon-carbon double bond on the right structure, this one, you have 2 alkyl group attached to the carbon-carbon double bond. So you have one alkyl group that is here, the other alkyl group that is here. But for the other one, you have 3 alkyl groups. The more groups or alkyl groups attached to carbon-carbon double bond, meaning more substituted alkene, is going to be faster, reaction or more stable product. And more stable product translates to major product as well. So if you have a choice of 2 products, the one that is major product, the one that is more stable is going to be the major product. And that's what we have here. Now, in theory, we can say that this is that is the case. We have more number of carbons attached to carbon-carbon double bond, and it's going to be the major product. But in the lab, we like to experiment this. And if we had our GC working, we could have actually do percent composition. When you do percent composition, which we couldn't do it because our GC is not working still. And we have a brand new GC sitting in the lab that is not working because of the electricity. So we have the problem is that we cannot do it. But if we were able to do the GC gives us 2 peaks. So you get like a triangle, 2 triangles. And where it says like to calculate the peak area, you do like height times half width, just like area of a triangle. The area under the triangle is proportional to concentration of each of the compounds. So if you have the total area and then you get the percent for each, you can say which one has higher percentage, which we cannot do that today, but we still study the experiment. You can include in the theory part of the lab report that the product on the left is going to be the major product because your product is highly substituted, has more substitutions around carbon-carbon double bond. And also you can explain about the mechanism of the reaction. So when you look at the mechanism for this reaction, this is dehydration. That means removing water. How do you remove water? You remove OH and you remove H. OH from the carbon that it carries the OH. That's like no-brainer, right? Right there. OH will be leave from here. And the hydrogen from the adjacent carbon. And we have a carbon on the left side, we have carbon on the right side. So OH would leave, and 1 hydrogen from either the left side or right side is going to leave. In order to make OH leave, OH is not a good leaving group. So in order to make it good leaving group, we have to protonate it. When you protonate, it would change to H2O, and H2O is neutral, is not very reactive, is not a strong base, is not a strong acid, so it's going to be good leaving group. So when H2O leaves, the plus charge is going to stay behind. You have a carbocation, 2 choice. Bring nucleophile to react with this, like you bring a halogen, so you have substitution reaction, or remove hydrogen from adjacent carbon. If you remove hydrogen from carbon B, which is on the right side, you would get this product to be on the here, because hydrogen B is removed. If you remove hydrogen from A, then you get this product. Okay, you get this product, and that is like a 1-methyl. So this is the mechanism for the reaction. Which one is going to be major product is the one that is highlighted blue now, but the 1-methylcyclohexane is going to be the major product. Even though we cannot prove it, but in theory, that is the case. What we can do today, after we mix our alcohol with the phosphoric acid and heat it up and do the fractional distillation, This is just discriminating that only the product will come in, not the reactant will go through the condenser. And then we don't put high flow of cold water here. We try to keep it, you know, room temperature. So the oily compound that is coming up, it doesn't freeze here, but we have to put ice around the receiving flask to make sure that condensation is complete and you don't lose the product, because if it comes as a vapor, then it can escape through here. So we are going to put ice around it, so as soon as the vapor reaches the receiving flask, it will change to liquid. When you are done with the distillation part, again, this distillation is combined with extraction. So we're trying to combine a you know, distillation with recrystallization or with extraction, to just remind the techniques that you have learned as well. So we have the extraction. So for extraction, you are going to add what you have collected to a separated funnel. You are going to add sodium hydroxide, because in this reaction, we know that we are using a lot of acid. There would be some leftover of acid. Sodium hydroxide is going to remove or neutralize the acid. The aqueous layer, it could be other impurities and water, because sodium hydroxide comes in form of aqueous solution. So when you're adding, and then the organic layer is going to be your products. The organic layer is not supposed to have water in there. So we are using, what are you using to remove the water? What do you use to remove the water from the organic layer? Calcium chloride is the anhydrous agent. Calcium chloride is used to remove the water, and you add enough of calcium chloride until the solution is clear. That means there is no water left. Then you measure the mass, you calculate the percentage. So since you have mixture of these two products, so you just say if you get 1 mole of this, you would get 1 mole of the product. So you don't have to divide that, how much of this compound you have, how much of this. You are adding the two together, as both of them are mixed. So use as 1 molecule, so it's going to be 1-to-1 ratio. Because if you use as 2 separate molecules, it would be 1, 2-to-1 ratio. Then you have to have 2 here. But since it's a mixture of these two, you can say that is a 1-to-1 ratio. So number of moles of the alcohol equals number of moles of alkene, which is a mixture of 1-methyl or 3-methylcyclohexane. Another test that you could do here is called the Bayer's test. In Bayer's test, you would add permanganate to the alkene, and if you add permanganate to alkene, is going to oxidize the alkene. Permanganate would be reduced itself, so permanganate would change to manganese dioxide. So it's an oxidation reduction reaction. Then we have that brown precipitate, and if the brown precipitate forms, then we know that we have the alkene as the product. So include this test, include the mass of the product, include the percent yield as the numbers that it goes into the abstract, into conclusion, so you can still defend the case that yes, alkene has formed for sure. You are going to skip this part of the calculation, part 3, because we didn't do GC, or anything that has to deal with the GC. You have to skip that, but you could do calculation for percent yields. But you cannot do separately, each one separately. You're going to have 1% yield for the mixture. Let me go back to chat room to get your questions. Maybe not, yes. Anything that has to do with GC, you cannot do it. You cannot calculate percentage. Oh, he didn't see this, but I guess I answered that. Calcium chloride, and it's used there. We are not doing the gas chromatography, so we don't have the percent composition. You cannot do all the calculation. Anything that is coming from GC, you cannot do. Any other questions? Was there any question that I missed from the chat room? Okay. No questions?
I have a question, actually.
Yes, yes.
For number 5 in the calculations, it wants us to calculate the yield for each of the two separately.
I know we cannot do each separately.
I was just going to ask if we do like a 50-50, we assume it's 50-50, but I guess not.
It's not, since we know it's not 50-50, so we cannot assume that. We're just going to say the total yields.
Okay.
We can say total yield. Yes, good question. Good. Okay, any other questions you might have? No? Okay. I'm going to call for attendance. If you remember any questions, you could ask me. And if not, after the attendance, you can start watching the video. Thursday. Okay, Thursday. Tarek? Deja? This is for attendance. Ashana? Elizabeth? Jennifer? Thank you. Jennifer? Alexis? Oh, Jennifer, you're here. Okay. Alexis? Kylie? Thank you. Colette? Valentina? Mariah? Catania? Anifal? Anam? So Anifal is not here. Sammy? Cassandra? Craig? Antonia? Okay. Let me know if you remembered any questions. If you don't have questions at this point, you may want to start the video now. Thank you and have a nice day.
Just one question.
Sure, I'm here. I'm just saying anyone who doesn't have question can go. Yes.
Right. So basically just from what we went over, we would only have to do number 4 for the calculations, and that would include doing the theoretical yield and then getting the actual yield from the tarred flask that we do in the experiment, correct?
Yes, number 4, exactly. Number 4, and then you do the Bayer's test also.
Right. And then we would also, in order to find the theoretical yield, we would have to convert the reactant to grams.
What do you know for reactant? Do you have mass or volume?
We have volume, so we would have to convert it using density first.
Exactly, very good. Yes, you have to convert that to using density. You would convert to the to mass, and then you get the moles. And when you have the moles, you multiply by molar mass of the product. The molar mass is going to be the same for both products. So you multiply by molar mass of the product, that gives you the mass of the product. Mass of product and reactant, basically it should be very similar, because all you're doing, you're taking 18 grams of water, but you're adding 15 grams of the methyl group. No, sorry, methyl group is there. So the mass of the product ideally should be less than mass of the reactant.
Right, yeah, I remember doing the problem yesterday, and I think the one of the masses was it was 96 grams for the methylcyclohexane, and then for the methylcyclohexanol, it was 114.
100 and something, right? Yeah.
Yeah, 114, very similar.
Yes.
Okay.
So it would be similar, but slightly lower because product weighs less than reactant per mole.
Right. Okay, so that was pretty much it. So we just use the volume, density, we get mass, mole ratio, multiply by the mass of product, get theoretical, and then actual we should get from the experiment experimentally. All right.
Exactly, yes.
Okay. All right. Well, thank you so much. If I have any questions, I'll
Thank you. Sure. The office hours, I'm going to hold office hours tomorrow, is going to be mostly chat, unless it's I see that is necessary, because I'm serving on a committee that they do interviews tomorrow. I'm going to hold the office hours, but I may not be able to turn on the video or the audio because they can hear me. But if needed, I will do it. I'm just going to have to put them on mute and answer the questions. But with the chat, we should be fine.
Okay, yeah. This experiment, either way, seems fairly simple in the grand scheme of things. It shouldn't be too bad.
You know, toward the end of semester, you have already passed all the challenges. I mean, all the obstacles, how I mean, for you, you got that right away after the first couple experiments. But it takes time to make it easy for you have to write the lab report, because everything, you know, it's the same procedure. So it's the same pattern, not the procedure, it's the same pattern. And then this experiment also is compared to experiment 7 is much more straightforward. Yes, you're right.
And then just not really off topic, but just thinking ahead a little bit, I think we have our final for you on April 8th.
Yes.
Right. Do you know what that's going to look like? Would it be similar to chemistry 2, where maybe you're going to test us on pre-lab questions and hypotheticals?
I think you would be the first one to find out which experiment has which video has the review for the final. But I do have a review as part of either experiment 9 or experiment 10. So during the review, I tell you sample questions or what to study, but you get questions from the procedure, you get questions from the calculation of percent yield, you get similar questions to pre-lab, and but I think the review is more complete than the short answer that I'm giving. But if you look at the review and you're not clear, I'm sure you will ask me same question again, which is good, and then I will explain more about at least the week before the final, definitely.
Right, and I assume that maybe the questions are going to come from maybe the first maybe 5 or 6 experiments, because those would be the fundamentals. It would be distillation, recrystallization, chromatography, because the first.
Yeah, I want to make sure that any questions. Sometimes I don't have the time to finish all the pre-labs. I want to make sure at least the pre-lab questions are graded. Any experiment that I want to include. That's one factor that is affecting. Sometimes organic 1 is more of the techniques, and you're right. The first few experiments they cover more techniques, so I emphasize more on that. But if there is experiment that I'm not going to include in the final exam, I will definitely let you know.
Okay. All right.
Yeah, just like last semester. Yes. Thank you, Tarek. Yes.
All right. Well, have a great day. Thank you so much.
Thank you. Thank you. Have a nice day.
You too.